Hey, again, you should be on page 422 when you're solving radical equations. Most of you will not find this to be that difficult or that different from solving regular equations, but we're going to have radicals in them. Square root of x plus 1 plus 2 equals 4. You only have one radical in this problem, and as you are solving, what you have to do first is get that radical by itself on one side or the other. So it's important that you make sure when you write down this plus 2 that it is not under that radical, that you write the problem down correctly. So we have the radical of x plus 1 under it, and then we have the plus 2. So first, we have to get rid of the plus 2 by subtracting 2 from both sides. So that leaves us with square root of x plus 1 equal to 2. Is the radical now by itself? Yes. So how would we get rid of a square root? Square both sides, which is exactly what we do. So that cancels. We have x plus 1 now equals 4. Solving for x. X equals 3. The one thing that you do have to do anytime you solve radical equations is check your answer. You have to. I know in all the classes you've ever had, they say you should always check your answer. Well, that's a should. This is not a should. This is a you have to. When you solve radical equations, you must plug it back in. You can do it in your head, but you must plug it back in. So you can't do it in your head, so you'll have to write it down. But either way, you've got to do it. So that would become 3 plus 1 plus 2 equals 4. What's the square root of 4? So we would get 2 plus 2. That does check. You don't have to show this step that you've done that, but if you write x equals 3 as an answer and it's really not supposed to be 1, you will get it wrong, and that will be possible on the test as well. So make sure you check. We'll probably, or we will do an example here where it will not, just to show you, and we'll talk about it more then. Maybe one more of the easier ones. Square root of x minus 2 minus 1 equals 5. That's what we need to do first. Add the 1. So square root of x minus 2 equals 6. Square both sides. X minus 2 equals what? 36. So what's our answer? What? 38. So if we check this, then 38 minus 2 under the radical would give us the square root of 36, which is 6 minus 1 is 5, so it does check out. You do get 38. The square root of x minus 15 equals 3 minus the square root of x. So what's different about this problem? There are two radicals. So all that you have to do when there are two radicals is make sure that they are on separate sides of the equation. This 3 really doesn't matter in this at this point, because if you subtract the 3 over, then it's just going to be on this side with that radical. So it's not so much getting the radicals by themselves anymore, as much as it is making sure that you have one radical on both sides. So if this had started off with, if you can picture this in your mind, if it had started off with plus square root of x, you'd have to subtract that over, like they've already done here, to get one radical on each side of the equation. So once you've got that point, you go ahead and square right off the bat. once you've got one radical on each side. So on the left, we have what? X minus 15 equals, how we do that? What? So you get
9 minus x.
Why you say it's not right? Because I didn't say yes, good job, and write it down. No, I said no, very bad job. You're the only one to do that? You gotta FOIL it. That is a binomial square. 3 minus square root x and 3 minus square root x. Multiplied together. FOIL. Must FOIL. There will be a ton of you that will write 9 minus x right there.
This guy.
So what's first? 3 times 3 up here. 9. Outside would be what?
3
Minus 3 square root x. Inside would be minus 3 square root x. And last, plus x. So can we combine any of those? We have 9. We have 2 of these. Negative 3 minus 3. Minus 3 minus 6. It would cancel if they were different signs. They're not different signs. And then you can't do anything with the plus x there. So make sure you FOIL that. Now what's the problem? We still have a radical. So now we're back to the first example. You've got to get this radical by itself. So what do we need to move? Subtract what? That'd work. That would be a fine first step. And you can, depending on how much advanced you are, you can move several things at a time. Just that's totally up to you. So we'd have x minus what? 24 equals negative 6 square root x plus x. Subtract the x. What's going to happen to that? Cancel out. We have negative 24 equals negative 6 square root x. Divide the negative 6 off. So we have square root x equals 4. So now the radical's by itself. Square both sides. What do we get? 16 equals x.
Only 2 of those, right?
Now what?
I gotta check that.
No, you're
Are you kidding me?
In the original.
Oh.
So what's 16 minus 15 right there? Would be the square root of 1. And over here, the square root of 16. And 3 minus 1. What? Sorry, 3 minus 4. What's the square root of 1? Does it work? Those are not equal. We didn't do anything. 16 is called, and you need to know this word, extraneous root. 16 is an extraneous root in that problem. Sometimes when you solve radical equations like this, you will actually create a root that doesn't even exist. That's why you have to check it. Sometimes it works, and that's why we learn how to do it, because it is valuable information as you're solving these problems, especially later in math classes. But you have to understand when you do things like this, when you square both sides of equations, you're actually raising that exponent. Each time you square it, you raise the exponent up 1. you create the possibility that you come up with roots that don't exist. You have to check each one. I will say, normally, when you only square one time, like we did in that first example, this answer will work out. The more times you square, the more possibility you will end up with an extraneous root. And we had to square twice. We squared in the beginning, we squared again down towards the end, and we did create an extraneous root.
Well, we had in our homework, they're like bigger exponents of square. Like 4 different cubes and stuff.
I see a couple down there. Let's do one more of those. Square root of x minus 12. Equals 2 minus square root x. I will also say, you'll begin to realize when you have these two terms over here that you're going to have to do what? FOIL. So I would not have this extra term with the one that's got two numbers underneath, if that makes sense. You're going to have to FOIL this. If you subtracted that 2 over and you had minus 2 on this side, then you would have to FOIL this side. I would FOIL the one with the smaller radical. This just has an x, this has x minus 2. This would not be the side I would want to FOIL. So we're ready to go ahead and square. Cancels. We have x minus 12 equals. You can just write it again there if you want to, however you want to do that. 2 minus the square root of x. So for our first term, we would have what? 4 outside minus 2 square root x minus 2 square root x. What? Plus x. So again, we have 4 minus 4 square root x plus x. And what can we do with the x's? We can just cross those off. You can see you're going to subtract that over. Those are going to be cons, hard to cross off an x. Subtract the 4. So negative 16 equals negative 4 square root x by negative 4. So square root of x equals 4. Do what? Square. X equals 16 again. Is that going to work?
Right now.
16 minus 12 up here would be 4. And we would actually have square root 4 or 2. And on the other side, 2 minus 4, square root of 16 would be 4. Square root of 4. I actually worked out the page. 2 does not equal negative 2. 16 is again an extraneous root. Do what? 2 doesn't equal negative 2. Tell me the stuff's difficult, and then you're laughing and goofing off. There you go. So do we have any radicals in this problem?
Yeah. You can make a radical.
You can make one, but do we have one? No. So there's another way that you can do this that I think is actually even a little bit easier, but you might not, we'll see. This is still, though, if you changed it, this would become your radical, right? So that's what you want to isolate, just like if it was a radical, you'd isolate it. What do we do first?
Add 2.
Add the 2 first. So we have 3, 5x minus 1 to the 1/3 equals 2. Divide both sides by 3 to get rid of that. So we have 5x minus 1 to the 1/3 equals 2/3. What do you do when you raise a power to a power? You multiply the exponents. What would we want to multiply times 1/3 to get rid of? Rear 1, that's what you do here. So we are going to raise this to the 3rd power, and we got to take this side to the 3rd power. So you're really doing the same thing. If you had written the cubed root of that stuff, you'd be taking it to the 3rd power. Either way. So that's going to cancel here. 1/3 times 3 is 1, so we have 5x minus 1 equals what? What's 2?
No. Yeah. No. 6 over 1. 32.
This is going to become 2.
No. That's something. It's like something 1/3. It's not 1. 2/3.
What's 2 to the 3rd power? 8. What's 3 to the 3rd power?
9.
27.
Oh.
I now see what you were doing.
Yeah.
This is not multiplying times 3 to give you 2.
Got it.
It's not multiplying times 3. That's an exponent.
So,
Yeah. Now we solve for x. We solve that for x.
divide by 5.
Add the 1.
Oh.
Keep it in fractions in your calculator. So 8 over 27 plus 1.
1.
What?
Oh,
35 27ths. Divide both sides by 5. Again, keep it in fractions. 7 over 27. Looks fun to plug in. You do have to do. So you got to plug 7/27ths in for your x. What's 5 times 7/27?
35. No.
35 over 27, and then minus 1.
And it'd be 8 over 27. Right?
Yeah, it's kind of undoing what we did to solve, right?
Yeah.
So it's possible we'll end up back where we were. What was it?
8 over 27.
Got to cube that.
Right.
But that's going to be big numbers. Oh, I had the wrong exponent up there. It's 3 or 1/3, not 3. So 8 over 27 to the 1/3 would take you back to 2/3 times 3. So now it is times 3, like you guys were doing earlier. Cross that off. What do you have? 2 minus 2, 0 does equal 0. The solution does check.
It's like a whole page.
The whole page. 7/27 is the correct answer. One more of those, or go on, no, or go on with your homework. Is that homework? Page 425. We will do two, 6, and 12 through 28. And that's on page 4.